Good morning, viewers. I am Saraswati from Computer Science and Technology Department. Now we are going to see about introduction to various search algorithm. Every search problem consists of a state space, start state, goal state, and the solution to the search problem. The sequence of actions is called the plan that transform the start state to the goal state. Goal state is the current state returns whether or not is the goal state. Every search problem is consist of a problem graph, strategy, and fringe. Fringe is a data structure which is used to store all the possible states. The tree, the solution plan, which is the sequence of node from S to G. These are the various types of search algorithm: uninformed and informed search. Uninformed search, depth first, breadth first, and uniform cost search. In informed search, greedy search, A star, best first search, and AO star algorithm. Depth first search algorithm. This is one of the searching algorithm for traversing or searching a tree or graph data structure. The algorithm starts at the root node by selecting some arbitrary node as the root node in case of a graph and explore all the possible nodes along each branch before the backtracking. It uses the last in first out strategy and hence it is implemented using a stack. But in BFS, it uses a first in first out strategy and it is implemented using a queue data structure. This is one of the main difference between the BFS and DFS. Breadth first search algorithm. In this graph, we have to move the node from S to G, find out the possible path for that node S to G. If we have to run the graph below. Here the initial node, yes. Goal node is a G. S have a branches A and D. And A have a branches B. And B have a branches C and G. C have a branches only G. And D also have a branches G. This is the graph for the depth first search. In the depth first search, the DFS traverses the tree to find out the deepest node first. It would always pick a deepest branch until it reaches the solution, and otherwise it goes to the next branch. The traversal is shown in the blue arrow in the diagram. Here, S will go through the A will go through the B will go through the C, and C is always go to G. This is the path, final possible path for the depth first search. Deepest search algorithm. The path is S to A to B, B to C, and C to G. D is the depth of the search tree. That is number of levels of the search tree. Ni is the number of nodes in a level I. We have to calculate the time complexity of the algorithm. Time complexity is calculated by the formula T of n. The T of n is equal to 1 plus n square plus n cube, etc. up to plus n power d. That is order of n power d. N is the number of nodes. D is the depth of the search tree. Space complexity. S of n will be calculated by O of n into d. N is a number of levels. D is a depth. The completeness and the optimality of a DFS algorithm. The DFS is complete. When it should be complete? The search tree is finite. It's meaning for a given finite search tree. The DFS will come out with a solution if it exists. Optimality. DFS is not optimal because the meaning the number of steps in reaching the solution or the cost spent in reaching its high. The path is a SDG. It does not find the optimal solution. The cost will be very low. Memory space will be very high. These are the main difference between DFS and DFS. And S is the depth of the solved solution. N is the number of nodes. In depth first search algorithm, we have to calculate the deepest node first. We have to analyze the deepest node and then all the branches in that particular deepest node, so that the memory cost will be increases and then cost factor is also increases compared to BFS. Thank you.